CCD versus Cmos. Which is better, CCD, that is charge coupled device, or Cmos, that is complementary metal oxide semiconductor? It depends, as there are advantages to both sensor technologies. For most applications, Cmos provides a better choice, but in others, CCD continues to hold its ground. Both use semiconductors to convert light into electrical signals. In a Cmos sensor, each pixel has a photoreceptor performing its own charge to voltage conversion and typically includes amplifiers, noise correction and digitization circuits, enabling the sensor to output digital data directly. The pixels typically don't store any charge. They simply read how much light is hitting that pixel at a particular moment and read out progressively from top left to bottom right, line by line, while the shutter is open. In a CCD sensor, light enters the photoreceptor and is stored as an electrical charge within the sensor, then converted to voltage, buffered and sent out as an analog signal with the shutter closed. A strong advantage for Cmos technology is that it provides digital output and can be controlled at the pixel level in ways that are not possible with CCDs. This provides potentially huge advantages in specialized imaging, where one might want to apply partial scanning or a particular control process to only a segment of the sensor. This capability is useful for control of cameras in different imaging modes for multispectral imaging or binning. CCD advantages over Cmos are the sensor's higher quantum efficiency, that is QE, and generally lower noise. The proportion of each pixel dedicated to light gathering versus being masked for other functions is also comparatively high. However, CCD cameras generally consume more power than Cmos, which can be a consideration for certain life science applications or for cameras which are battery powered. Blooming is an unwanted CCD specific artifact which appears as a vertical smear line when a bright light or saturation occurs in the image. Probably the most significant issue when deciding between CCD or Cmos is global versus rolling shutter. Most Cmos sensors today use a rolling shutter which is always active and rolling through the pixels line by line from top to bottom. CCDs, on the other hand, store their electrical charges and read out when the shutter is closed and the pixel is reset for the next exposure, allowing the entire sensor area to be output simultaneously. When the shutter is open, the CCD receives light and accumulates charges again. The videography markets are in a state of transition from CCD cameras to Cmos, largely in part due to economies of scale in Cmos manufacturing. If you have wondered why camera makers are all using Cmos over CCD cameras, it's simply because the end users prefer them because of cost, size and convenience. Hopefully, this article has helped those wondering what a Cmos camera is or means. It's just the type of image sensor. Conclusion: CCD and Cmos sensors have different advantages, but the technology is evolving rapidly and the situation changes constantly. Hence, the best strategy for a camera manufacturer is to continually evaluate the test sensors for each and every camera that is developed. The question whether a chosen sensor is based on CCD or CMOS technology then becomes irrelevant. The only focus is if the sensor can be used to build a network camera which delivers the image quality needed and fulfills the customer's video surveillance requirements.